All right, so in this lesson, we're going to be looking at inverse trig functions. You got a taste of them during previous homework because when you wanted to find an angle, you took the inverse trig function. So inverse trig functions, their input is a value, so something like 1, okay? And their output is an angle, so i.e. pi over 2, okay? So whereas normally, up until now with our trig functions, we've been giving it an angle and then getting a number out, we're going to get a number and give an angle back, okay? So first things first, the three trig functions we're going to be looking at, all right? We've got arcsine, or sine inverse, like it would show up on your calculator, like so. We've got arc cosine, or cosine to the negative 1, like it would be on your calculator, and arctangent, or tangent to the negative 1 of x. And the reason why we're doing this is so that we can figure out trig function values, or in this case, the inverse trig function values, without a calculator. So the definitions are y is equal to arcsine of x, so you're going to give a function value, get an angle out, if and only if sine of that angle is equal to that function value, okay? So that's important. So it only works if the same angle gives you that correct function value. Now, the slight hiccup is where your output can be. Okay, your range is limited with arcsine, and that's because trig functions are periodic. So there can be more than one answer, right? But we only want one. So you are trapped for your angles between pi over 2 and negative pi over 2. So that means you have 0 to 90 and 0 to negative 90. Not anything greater than that or anything smaller than that in the case of the negatives, okay? For arc cosine of x, y is equal to arc cosine of x if and only if cosine of y is equal to x. And this one's also bounded, but this time it's between 0 and 180. Okay, so anything larger than 180 is not an option. Anything smaller than 0 is not an option for your answer for cosine. And then y is equal to arctangent of x if and only if tangent of y is equal to x. And this one is trapped as well, similar to sine, between negative pi over 2 and pi over 2. It's just not inclusive. So you cannot get 90 and negative 90 as answers, but you can get everything that is smaller than 90 and everything that is larger than negative 90. Okay? And if you notice on the side, I drew little pictures. If you have room on your card, that would be, I find, useful to just draw that little picture so you know that you're between those two with the numbers, the angle numbers delineating your axes here. Okay, so let's look at some examples. In number 2, they want us to find arcsine of 0 without a calculator. So first thing I'm going to do is set it equal to y because that's going to be my output, right? And I know I'm going to get an angle. And then I'm going to use definitions of inverses to say that sine of y has to be equal to 0. So sine of our angle has to be equal to 0. So then if we look at where we're bounded, 0, pi over 2, negative pi over 2, sine is 0 only at the 0 value for y, because at that point we've got 1, 0. Okay, so again, you're going to be using your unit circle here. It's just going to be a little limited compared to what you usually have. And so that's our answer. For 4, we want arc cosine of 0. So again, we're going to set this equal to y. Cosine of y is equal to 0. So again, I'm going to draw. So we've got 0, pi over 2, and pi as our options. At 0, cosine is 1. At pi, cosine is negative 1. And at pi over 2, cosine is 0. So y is pi over 2. And now for 6, we have arctangent of square root 3. So we know that we're going to set this equal to y. So we get that tangent of y is equal to square root 3. Right? So this tells me that sine of y over cosine of y is equal to square root 3 over 1. Okay, so I need to find where sine is square root 3 and cosine is 1. Our tangents between 90 and negative 90. Since sine and cosine are positive, I must be in quadrant 1. And then the angle that works here is when the reference angle is pi over 3 or 60. So y is going to be pi over 3. For 8, we want arcsine of negative square root 2 over 2. So again, first step I'm going to do is set this equal to y. Rewrite this as sine of y is equal to negative square root 2 over 2. And then I'm going to draw. Okay, sine, I either am in quadrant 1 or quadrant 4. In quadrant 1, sine is positive. In quadrant 4, sine is negative. So I know that I'm going to be down here. I know that this side is negative square root 2 over 2, right? And so the only angle I could have here is 45 degrees. And since we're moving in the negative direction, that means that we have y equals negative pi over 4. Okay, let's look at another one. For 10, we have arctangent of negative 1. So again, I'm going to set this equal to y. I get tangent of y must be equal to negative 1. So this is where sine and cosine are the same. Tangent is positive in quadrant 1, negative in quadrant 4. So I'm going to draw my triangle in quadrant 4. And I want cosine and sine to be the same. That's only when we have a 45 degree reference angle. So y is negative pi over 4. And that's it. So now that we've kind of touched and done a lot of examples here on finding inverse values, or angles in that case, we're going to look at some properties of inverse trig functions. So since we're doing inverses of trig functions, it would make sense that if we took sine of arcsine of x, we'd get the trig function value back out, okay? Because we're doing sine of some angle is equal to a value. Whereas if we took arcsine of sine of y, we'd get a trig function value and an angle out, because we're doing arcsine as our outer function, so then we should get an angle out. So essentially all it's saying is that if you took the sine of each side, or the cosine, or the tangent, you should get your trig function value out. Whereas if you took the arcsine of each side, or the arccosine or arctangent, you should get the angle value back out again. Okay, and this is going to be useful for when we start doing these next couple examples, because we're going to use that property to allow us to solve for what we're looking for. So in 38, we've got this triangle here. That's a right triangle with adjacent side being 4, hypotenuse being x, and we're looking at theta. And what we want to do is find an expression for theta in terms of x. So essentially we want to make, some sort of equation for theta. So what we're going to do first is notice we have adjacent and hypotenuse, which is equal to cosine. So cosine of theta is equal to 4 over x. And so I'm going to use this property, arccosine, taking the arccosine each side to get my angle value. So I'm going to take arccosine of the left, so that's cosine theta, equals arccosine of 4 over x. So whatever you do to one side, you have to do to the other. You can't just do, one side and be done with it, okay? So then, by the properties, arccosine and cosine cancel, so I'm left with theta is equal to arccosine of 4 over x. And that's it. There you go. Okay? So then that's what you're going to be doing for 37, 39, and 41, and they're all very similar to that. I did do those examples in the notes. For 44, they want us to simplify the expression given. And what's nice is they gave it to us in terms of one of our properties. They gave it to us as tangent of arctangent of x equals x. So all we have to do is find out what it's equal to. So tangent and arctangent cancel, and we're left with 25, like so. Okay? Let's look at a little more difficult one, though. For 48, we've got arccosine of cosine of 7 pi over 2. Now here's the issue. 7 pi over 2 is greater than pi. So we're not in our boundary like we need to be for, for our trig function. For our inverse trig function. So what we have to do is we have to evaluate cosine of 7 pi over 2 to a number that we can use for our cosine. So we get this is going to be -1 because we go around once and then around a second time, and we end up here. And cosine is 0, 1, my bad, 0, -1. So we've got cosine of 7 pi over 2 is equal to 0. Now, the reason why we have to do this is because we have to be between 0 and pi for our answers for our cosine, and currently we wouldn't have been. We would have been equal to 7 pi over 2. So now that we have a 0, we're going to replace that for cosine 7 pi over 2. Okay, and so arc cosine of 0 is where cosine is 0 in between 0 and pi, and remember from the last slide, that's at pi over 2. So this is our answer. Okay? Now let's look at ones that don't fit perfectly into our inverse properties. Okay, so in 52, they tell us that we need to find the exact value of sine of arc cosine of square root 5 over 5. Okay, and remember, I said this in the last slide, but this portion right here is an angle. Okay, so really what we're looking for is sine of theta. But the problem is we don't know what theta is. They didn't tell us what it is. So what we have to do is find a triangle that fits around theta. So we're going to draw a triangle. Theta, right angle. Okay, and they tell us that arc cosine is square root 5 over 5. So what that tells us is that cosine of theta is equal to square root 5 over 5, right? So that means that our adjacent side is square root 5 and our hypotenuse is 5. And so we're going to do Pythagoreans to figure out our remaining side. So we end up with square root 20 or 2 root 5, okay? And what we want to find is sine theta. So sine theta is opposite our hypotenuse. We know our opposite is 2 root 5 and our hypotenuse is 5. So there's our answer. Okay, let's look at another one. For 56, we have tangent of arcsine of -3/4. Remember, arcsine of -3/4 would be in the 4th quadrant, okay? And what they tell us with arcsine of -3/4 is that sine of theta is equal to -3/4. So we know that our opposite side from theta is -3, and our hypotenuse is 4. So having this, we do Pythagoreans again, and we get square root of 7 for our x value on our triangle. So what we really want, though, is tangent of theta, because that's what that says right there, right? Tangent of arcsine of -3/4. So tangent of theta is actually going to be equal to -3 over root 7, and if you want to rationalize, that's -3 root 7 over 7. Okay, let's look at a couple more. For 58, we've got cotangent of arctangent of 5/8. Okay, so there's two ways to solve this. You can either draw a triangle for arctangent for that theta value and solve for cotangent, or we can use properties. Now, cotangent is defined as 1 over tangent. So this is equal to 1 over tangent of our angle, which is arctan 5/8. And if you remember, when we take the tangent of an arctangent, it's just the function value. So this is 8/5. No triangle needed. Now, this only works when you have the inverse trig function here, okay? So in this case, we got tangent. If you don't have this, you cannot do it, all right? Now, let's look at 64. In 64, and pretty much the rest of this assignment, you're doing the same stuff. It's just now, for I think it's 59 to 67, you are doing it in terms of variables rather than numbers. That's the big difference, okay? So again, first thing they tell us is that they give us this theta for arctangent, right? So tangent theta is 3x. So I'm going to draw a triangle that matches that. We've got a theta here. 3x, this means it's 3x over 1. So we've got 3x and 1. So then we do Pythagoreans to figure it out. So that's 9x squared plus 1 on the hypotenuse there. Okay? But what we want to find is secant of that theta, because arctangent 3x is equal to theta. So secant of theta is 1 over cosine theta, which is 1 over square root 9x squared plus 1. So this is square root 9x squared plus 1. And that's it. That's the lesson, okay? You will have the entire class period on Thursday, well, majority of it anyways, as much as we can get, to work on this assignment. It's page 610, 1 through 15 odd, and 37 to 67 odd. Reminder, your test is still going to be next week, Monday, so I'll write that down. And you will be allowed the use of a calculator as well as your note card. I will be available during class on Thursday for any and all questions you may have, even if that means I end up writing on the board, okay? I just wanted to give you guys the full period to work on this assignment, since it is going to be, the test is still going to be before spring break, so I wanted to give you more time to kind of sift through the material, okay?